Okay, so let's get started. We're going to be taking a look at working with our oscilloscope function within our Motec M1 software. Also a function that allows us to monitor input-output statuses, seeing the voltages or what's going on with a particular input or output we've assigned. These are very good diagnostic tools, which is just a basic introduction of how to work with them and how to use them. We'll be digging into setting up our cam and crank sensor patterns and all of the specifics in the next tutorials coming up here. So how we deal with a Hall effect, cam and crank trigger pattern, and how we deal with a VR or magnetic style trigger pattern. And we're gonna be using this capture input or oscilloscope option within those tutorials as well. But this again, is just an introduction to what we have to work with in our software. So right now I am connected to my M150 box. We can see up here at the top, it's showing a connected status. The engine is not running. We can see here the engine speed is showing 0 RPM. If we skip over from our workbook that I have here provided with our training course into the setup here, and then under our ref sync window, this brings us into configuring all the things for our crank trigger and our home, which they're going to call synchronization within the software. So looking at this, we have a lot of specific details that we need to know, such as our engine speed, pin hysteresis, the debounce. We have that both for the synchronization as well. And then we have a lot of parameters in here that we need to configure. Now, in order to figure out what camera crank pattern we're working with, we could perform an oscilloscope capture as we're cranking our engine over. And this will tell us a lot of information. The number of teeth on our crank trigger, if we have a missing tooth or not, and then how many teeth on our home or synchronization that will have our cam input. So this information is going to be something that we either will know already before we head into calibrating and tuning the engine we're working with, or we have to actually determine it if we don't know, we haven't taken apart the engine and looked at the trigger wheel and looked at our home wheel and seeing how many teeth and what pattern we're working with. We can use an oscilloscope to tell us a lot of this information. Now, we're not going to get into programming anything specific here in this training module in terms of all of our parameters to work with here. We'll be looking at that again in the next two tutorials coming up. We'll be digging into how to program this for a Hall effect or a VR magnetic style sensor, but we need to understand how to work with this basic oscilloscope within the software. Now, if we go up here into the top portion of our window, we're going to go into the online area and then go down here and we find we have a capture inputs and we have a monitor input output. Both of these we can see aren't grayed out because I am in the online status. I'm able to go here to capture inputs. This allows me to use this very basic oscilloscope type of function within the software. Now, it's not going to be a very in-depth oscilloscope. So if you're used to working with a scope, an external scope, that's going to be a bench scope or a laptop specific scope, you have a lot more functionality in terms of digging into the scope trace or scope capture. Here, it's just going to be essentially the basics. It's going to give us the pattern that we can count, and we were able to take a look, zoom in, zoom out at some things within the capture that we're dealing with. The monitor input output is going to be allowing us to monitor various input and outputs that we've assigned. We'll be looking at this here in just a second, but both of these are something that you should definitely need to know where they're at in the software and how to use them in case you're trying to troubleshoot a circuit that you're dealing with. So the capture inputs will be only used for any universal digital inputs. If we're talking about our crank trigger, that's going to always be on universal digital input 1, and the synchronization is typically universal digital input 2. That's how I have my particular engine wired here with my M150. You'll find that you're probably going to see that same exact thing in terms of where your cam and crank sensor signals are going into for your Motec. So any universal digital inputs, we can use the capture input to do a basic scope trace and figure out if that channel is active, how many teeth we have, what type of pattern it's producing. So you can use this for wheel speed sensors or flex fuel composition sensor, anything that's a digital input, we're able to use this. Let's go here to our capture input and take a look real quick. Now in our window here, it's going to ask us a couple things. We can load a file, and that's going to actually allow us to load an existing capture input file that we can create. So we can create this. We'll talk about that here in a second. Under the new, create the file, we'll save it. We can send that to someone if we're working with, let's say, a tuner or Motec, and they're trying to troubleshoot what's going on with their engine. They're able to look at that and review it. So that's where we can load a file that we've created already. And we go here to new. This creates a new file or new capture. So let's go take a look at new. Now it's going to ask me,
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.